Okay, so let's go and look at another example real quick. Say you just had a constant, so say it was like 8 dx right there. What's the antiderivative of that? And even though it doesn't look like the power rule, you could kind of use it because you could think of there's like a imaginary x to the 0 there, and you'd add 1 to the exponent and divide by that. And it would work out perfectly, but you just have to think, too. Just think of it in a simple way. What function, when I take the derivative of it, becomes 8? And it would just be 8x plus c. So any constant, whenever you have a constant there, you just essentially are adding an x with it, or whatever variable you're using. I've always used dx here, but you could have d theta, you could have dt. There's different variables you could use besides x. All right, let me just give one last example here on this with a whole bunch of stuff in it. So say you had 3 minus 1 over the cubed root of x plus 5x to the 9th. All right, so here we have multiple terms within one problem, and it just works out the same as the previous one. So you just look at each term individually and find the antiderivative. So before I do the integral of this, I'm going to rewrite it because of this term. The other terms are ready to go, but this one I need to bring that up and write it as, instead of a cubed root, to the 1/3 power. So I'm going to make it x to the negative 1/3 power, since it's on the bottom, plus 5x to the 9th. Okay, now it's time to take the antiderivative of this. The antiderivative of 3 is just going to be 3x minus, so here for this I'm going to add 1 to the exponent, so that'll become 2/3. And then I'm going to divide by 2/3, but like I said before, instead of dividing by 2/3, I'll multiply by 3/2. So it'll be 3/2 x to the 2/3 plus, and this will be 5x to the 10 over 10 plus c. And if you want to, you can go ahead and simplify that to just x to the 10 over 2 plus c. But there you go. So that's antiderivatives.